and welcome to tutorial 3 on the Edexcel S2 crash course that we're doing here on YouTube. This one is on continuous random variables. Please, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths or follow me at Mr. Arnold's Maths. Right, so continuous random variables. The first thing we're going to talk about is the probability density function. So a probability density function is essentially it's a graph, it's a curve, it's a function such that f of x must be always bigger than 0. Okay, it can't go below the x-axis, and the reason for that is because this has all to do with probabilities, and we can't have negative probabilities. Also, a probability is found by calculating the area beneath the graph. And in order to do that, from your S2 course, or sorry, not your S2 course, your C2 course, you should know that if I want the area beneath this curve, what I do is I integrate f of x dx. So I integrate with respect to x between the values a and b. So my integral is evaluate between a and b. And also the other thing that we need to ensure that the function, if I take the integral between minus infinity and infinity of f of x dx, that must always be equal to 1, because the total area beneath the curve must come up to 1. The total area equals the total probability, and the total probability is always 1. Okay, let's just have a few look at a few examples here. Let's start out by finding a constant k, which often appears in some questions. So, suppose I'm told that the random variable x has a probability density function defined as such. So it's k times x, kx times 4 minus x when x is between 2 and 4, and otherwise it's 0. So the first thing we got to do is find the value of k, and then finally we're going to have to sketch the PDF, or the probability density function. So let's start by looking for k. Well, we should remember from the video, from the previous slide, that the area beneath the graph is must total 1. So if I integrate f of x, between 2 and 4, it must be equal to 1. So integrate f of x between 2 and 4, it must be equal to 1. The reason why I'm saying it's equal to 1 in this case was the total area or total probability must equal 1, and it says that my function f of x has a value of 0 otherwise when it's not between 2 and 4. So all of this must have a total area of 1. So what we're going to do is we're going to integrate between 2 and 4 kx times 4 minus x, and don't forget your dx at the end as well, because we're integrating with respect to x, and that must be equal to 1. So hopefully you remember from integration that we can take any constants outside the integral sign. So I'm going to integrate. In fact, let me just lower this a little bit. So I'm going to integrate between 2 and 4 of, and I'm going to multiply this in as well, just to make life a little bit easier. So it's going to be 4x minus x squared. 4x minus x squared dx, and that must be equal to 1. So that's going to be k times, well, integrating 4x gives me 4 over 2 x squared, which is 2x squared, and integrating this I get minus, and I tend to write it like this, 1/3 x cubed. And we're integrating that between 2 and 4, and that must be equal to 1. Let's just find a bit more space. So k into, and I'm going to put 4 in here. We get 4 squared is 16. 16 times 2 is 32. Minus, and then 4 cubed is 64, so it's going to be minus 64 over 3. And we've got to subtract, now putting in 2. 2 squared is 4. 4 times 2 is 8. And then 2 cubed is 8, so it's going to be minus 8 over 3. And that must be equal to 1. Okay, so it's going to be k times all of this, and when we tidy up all of this, you can use your calculator if you wish, we're going to get 16 over 3 equals 1. So dividing both sides by 16 over 3, we get k equals 1 over 16 over 3, which is 3 over 16. So I know k is 3 over 16. And then the final part of the question is to sketch the function. So let's rewrite the function now. The function is f of x, and it's defined as such. We get 3 over 16 times x times 4 minus x, and that's between 2 less than or equal to x less than or equal to 4. And then everywhere else it's 0. Okay, so I'm going to draw a set of axes. Let's get the arrow on here. So again, we're just sketching the function here. The y-axis is f of x, and then the bottom is x. And if I label this point 2 and say label this point 4. Now I know that between 2 and 4 it follows this path, whereas everywhere else it's 0. So what I need to do is I need to make sure that the examiner can see that. Let me choose a different colour. I need to clearly show that it's 0 otherwise. So I'm just going to mark along here that it's 0. And then after 4 it's also 0. And then the other part that I need to work out is, well, what's this going to look like? It's a negative x squared, which means it's going to curve down like this. It's a negative x squared, so it's going to curve down like this. The maximum is going to come when x equals 4. So if x equals sorry, not when x equals 4, when x equals 2. Let's see what happens when x equals 2. When I put 2 in here, I get 4, take away 2, which is 2. And then 2 times 3 is 6, and then 6 times that 2 is going to give me 12. So I end up with 12 over 16, which is 0.75. So I just subbed in x equal to 2 in here, and when I do that, f of x equals 0.75. So what we can do is mark up here 0.75. If I put x equal to 4 in, I get 4 minus 4, which is 0. So 0 times all of that is going to be 0. So I know that my function, let's get the right colour here, is going to follow this type of path. It's going to come down, curve down like a parabola, and touch here. And what I can do here, just to kind of bridge this gap, I can put a dotted line just so that we can see what's going on here. So as the graph approaches 2, it's 0, 0, 0, 0, and then when it gets to 2, it actually jumps up here and then follows this path, comes back down, and then is 0 everywhere else. And the total area beneath this curve would actually equal 1. Okay, let's crack on with another example. So I've got a continuous random variable x. It's got a probability density function given, and we're asked to find the value k and then sketch the PDF again for all values of x. So this is a slightly more tricky example, but again, I know that if I integrate it, the area under the curve in total must be equal to 1. So for part A, I need to find k. I need to integrate between 0 and 2 of k and that's with respect to x, k dx. But also I'm going to have to add on the integral between 2 and 3 of k times 2x minus 3. With respect to x. And I know that everywhere else it's equal to 0. So we got some fairly straightforward integration here, and I can factor out the x. So I'm going to factor out x from both functions, and also remembering that when I add these together it must equal 1, because the total area under the curve must equal 1. So let's factor out the x. So factoring out the x, I'm integrating between 0 and 2 dx, plus I integrate between 2 and 3 of 2x minus 3 dx, and that must equal 1. Again, we factored out the k to make life a little bit easier, and the integral of dx is x, so we get x, and I need to evaluate that between 0 and 2, and then I'm going to have to let's integrate this one now. So the integral of 2x is going to be x squared, and the integral of minus 3 is going to be minus 3x, and that has to be evaluated between 2 and 3, and the total when I add it together must equal 1. Okay, so we get k into, well, when I plug in 2 here, I get 2, and then 2 take away 0 is 0, or sorry, is 2, plus, and then putting 3 in, 3 squared is 8, or is 9, I beg your pardon. 9 take away 3 times 3 is 9, and then we need to take away from that 2 squared, which is 4, minus 3 times 2, which is 6, and that's equal to 1. So k times 2 plus, well, 9 minus 9 is 0, they cancel out nicely, and then 4 minus 6 is minus 2, so I've got 2 minus minus 2, which is 2 plus 2, and that must be equal to 1. So we get k must be equal to 1/4. Okay, so now let's redefine our function over here. Let's redefine our function. So f of x, my PDF is going to be equal to, we get 1/4 when 0 is less than x is less than 2, is 1/4 times 2x minus 3 when 2 is less than or equal to x is less than or equal to 3, and then 0 otherwise. I'm just going to write OW just to save me a little bit of time. Okay, and then the second part was to sketch the PDF for all values of x. So we don't want to do it that way. There we go. Okay, so this is crooked. Let's make it not crooked. There we go. This one, f of x here and x here. Now, between 0 and 2 it has a value, and then between 2 and 3 it has a value. Everywhere else it doesn't. So I'm going to mark this as 2, mark this as 3, and that's 0 there. So it doesn't have a value when it's less than 2. The function is 0. So that would be a straight line in a perfect world, and this will also be a straight line in a perfect world. And I know that between 0 and 2 it has a value of 1/4. f of x is equal to 1/4. Well, that's just a straight line. So if I say that this is 1/4 here, f of x. I'm going to do my very best here to make this line straight. Not too shabby. So between 0 and 2 it has a value of 1/4, and then this we can see here it's 2x minus 3, so it's a linear relationship, which means it's a straight line, and the gradient of this line is actually going to be a half. So we can see, well, what's the value going to be when x was 3? So 2 times 3 is 6. 6 take away 3 is 3. 3 times 1/4 is 3/4. So when x is 3, we get a value of 3/4, and I know that it's a straight line. That means it must go up in a straight line, up as far as 3. And then what we can do is we can drop down our dotted line to say that after 3, it travels along using it travels along equal to 0. Okay, a couple of exam questions to do now. So, show that k equals 1/9. So we've got a continuous random variable, that's the PDF here, and this is from January 2010, question 4. So again, we're going to integrate. So I know if I integrate between 0 and 3 of k times x squared minus 2x plus 2 dx, and I add the integral between 3 and 4 of 3k dx, that must equal 1. The total area under the curve must equal 1, because it's 0 everywhere else. So, make a wee bit of space for us. Okay, so I'm going to factor out the k again like I've done before. So I'm going to factor out the k, and I'm going to integrate this at the same time. So when I integrate x squared, I get 1/3 x cubed. Integrating this, I'm going to get minus x squared, and then integrating this, I get 2x. And that has to be evaluated between 0 and 3. Plus, I'm integrating 3dx here, which is going to give me 3x. And that has to be evaluated between 3 and 4. And all of that must equal 1. So, k into, right, let's put the 3 in. 3 cubed is 27. 27 over 3 is 9. Minus 3 squared is 9. And then I got to add on 2 times 3, which is 6. When I subtract away from that, well, I put 0 in here, I'm going to get 0 all the time. Every one of those is going to give me 0, so we don't need that bracket. Okay, moving on. Let's do this one. 4 times 3 is 12. And then 3 times 3 is 9. So I'll take 9 away. When I do all that, I should get an answer of 1. Hopefully we end up with 9 in the brackets. Let's see, 9, take away 9, 0. 12 and 6 is 18. 18 take away 9 is indeed 9. So k times 9 is 1, which means that k must be equal to 1/9. And there we go for our 4 marks. Alright, another example here. We got our PDF. Maybe you want to have a go at this one yourself, because I mean they're all pretty much the same idea. I need to show that k is equal to 1/5. So I know if I integrate between 0 and 1 of a half x, and I add the integral between 1 and 2 of kx cubed, and you know what, I forgot my dx, very important to have the dx there as well. We're integrating with respect to x, and that's equal to 1. When I add these together, it must equal 1, because everywhere else the PDF has a value of 0. Alright, let's find a bit of space. So integrating a half x is going to give x squared between 0 and 1, and I need to add k times, and then x cubed integrated is going to give me a quarter x to the 4, and that must be equal to 1. Okay, so we sub in here, we get 1 plus, and this is integrated between 1 and 2, so k into, alright, 2 to the power of 4, 2, 4, 8, so we get 16, and 16 divided by 4 is 4, and then put 1 in, we get a quarter, so it's going to be 4 minus 1 quarter. That should equal 1. Okay, now something's not quite right here, hang on a second. We got x squared. What was I thinking? When I increase the power to 2, it increases by 1. I should then divide by 2, and a half divided by 2 is actually a quarter. So a bit of a mistake there, but luckily we found it. So it's not 1 here, it's going to be 1 squared times a quarter, which is 1 quarter. Okay. Right, so we get k times, and then 4 minus a quarter is going to be 15 over 4. So we get 15 over 4. And at the same time, I'm taking a quarter away from both sides. So 1 take away a quarter is 3 quarters. And then the final part, divide both sides by 15 over 4. And 3 quarters divided by 15 over 4 is 1/5. If you don't believe me, 3 quarters divided by 15 over 4, well, 3 quarters times by 4 over 15. They cancel out, give me 1s, and then 3 goes into 15 5 times, so we get 1 over 5. So k equals 1 over 5, which is exactly what we wanted. Alright, we've got one more example to go. So, another exam question here. We got our PDF given, and we're asked to sketch f of x for all values of x. So, nice question for 3 marks. Okay, let's have a think about this now. So when x is between 2 and 3, it has a value. So call that 2, say 3, 2 and 3. Everywhere else it doesn't have any probability. So the function is only defined between 2 and 3, everywhere else it's 0. And what is this function? Well, it's 2x minus 2. So it's a linear function, which means it's going to be a straight line. If it was 2, if x was 2, f of x would be 0. So that's correct. If x was 3, we'd have 3 minus 2, which is 1. And 1 times 2 is 2. So when x is 3, we get a value of 2 for f of x. And this is f of x, so it's going to be a straight line going up like that. Do use a ruler for this, and then it drops down. Okay, right, that's a handy 3 marks there. Let's move on. And before I do, actually, on to the next section, really important that you do put this in your function, okay? Really important. Alright, okay, let's talk about the cumulative distribution function. Essentially, we know that we've dealt with cumulative probabilities before, and we've also come across this before when we did discrete random variables. This is continuous random variables, but it's the same idea. The big f of x is just telling us the probability that our random variable is less than or equal to a particular value of x. Now, don't get bogged down on all of this notation. It's in the textbook. It's not all that important. The crucial part is that when we integrate the probability density function, we get the cumulative distribution function, and when we differentiate a cumulative distribution function, that takes us back to the probability density function. Okay, so this part here is the crucial part. As always, the area under the curve is the probability. So let's have a look at an example here. I've got a random variable x with a PDF given. I'm asked to find the cumulative distribution function. Now, there's a couple of different ways of doing this. I'm just going to show you the one. I'm going to show you the one which I think is the easiest one to do. And I mean, you're welcome to look at the one in the textbook and see if you prefer it, but my personal preference is just this one, and for time purposes we're just going to stick with one method. Okay, so like I said before, to go from the PDF to the CDF, we integrate. So if I integrate 1/5 dx, if I integrate that, what are we going to get? We're going to get, and remember this, we're not actually putting any limits in here. In the other method you do use the limits. This method we're not going to use any limits. So integrating this, I'm going to get 1/5 of x plus c. Okay. Now it's really important that I know when x is equal to 1, the probability is 0. So essentially I know that 1/5 of x plus c equals 0 when x equals 1. Okay, because we only start to get probabilities when x is bigger than 1. That's when the probability starts to come in. Now I'm not going to sketch the curve, but we have, what is it, 1/5 there, and then we've got a linear relationship, so it's gonna be something like that. Now before x equals 1, the function has no probability. There's no area under the curve. Okay, so I know that 1/5 of x plus c equals 0 when x equals 1. So substitute x equal to 1 in, I get 1/5 plus c equals 0, which means that c equals minus 1/5. Okay, now we'll come back to this in a moment. What I know now is that this is actually 1/5 of x minus 1/5. So that's the first part done. Now I'm going to integrate this. So I'll just draw a little line here. So I'm going to integrate 1/5 of x minus 1 dx. Now I'm going to factor out the fifth here because I can. It's a constant, so factor out the constant. 1/5 of x minus 1 dx. So we get 1/5 of 1/2 x squared minus x plus d. Now I've made a little mistake here again. I shouldn't have put my bracket up yet because I factored out that fifth. So x plus d. So I'm using d. I've used c already, so I'm going to use d this time. And the other thing I know is that when x equals 4, when it gets to 4, which is going to be around about this part here, when x equals 4, the probability, the total probability at this point is going to be 1, because the maximum area under the graph is 1. So when we get up to here, 1/5 of 1/2 x squared minus x plus d, that equals 1 when x equals 4. So let's plug in x equal to 4. We're going to get 4 squared. 4 squared over 2. And 4 squared is 16. 16 over 2 is 8. You're going to have 8 times 1/5, which is 8/5. Minus 4. 4 times 1/5, which is... I'm making this very, very complicated for myself in hopes of me trying to save time, but let's actually just multiply both sides by 5. That'll be easier. multiply both sides by 5, and I'm going to substitute in the 4. So half times 16 minus 4 plus d must equal 5. And then solving for d, that's 8. 8 take away 4 is 4, and then 5 take away 4 is 1. So d is 1. Now, d is 1, which means that this is now 1/5 into a half x squared minus x plus 1. And it's 0 otherwise. Now what we can do is we can actually write down our function f, big F of x. Now big F of x, I know, has a cumulative probability of 0 when x is less than 1. And then when x is between 1 and 2, less than or equal to 1, should I say, when x is between 1 and 2, we have a value of this, a function of this, 1/5 x minus 1/5. 1/5 of x minus 1/5. And that's when x is between 1 and 2. And then when x is between 2 and 4, so when x is between 2 and 4, we get this, which is, I'm going to multiply in the 5th here, which is going to give me 1/10 of x squared, 1/10 x squared, minus 1/5 of x plus 1/5. And that's when x is between 2 and 4. So 2 less than or equal to x less than or equal to 4. And then when x is bigger than 4, when x is bigger than 4, we know that the cumulative probability is going to be equal to 1. Okay, I think we're going to need to see another example, another one of these. So just remember, we went from a PDF to a CDF, right? PDF to CDF is integrating. Now what we're going to do is we're going to go from a CDF back to the PDF and work out some probabilities. Alright, let's start with part A here. So I want to find the probability that x is less than or equal to 1.5. Well, first of all, I have to see which region, which part of the function am I going to use. 1.5 is in here, so I'm going to use this one. So to find the probability that x is less than or equal to 1.5, remembering that the probability that x is less than or equal to x is actually the same as the cumulative value of x. So I can just do f of 1.5. That's what we're going to do for part A. We're going to do f of 1.5. And I'm going to use this function. So it's 1/5 times 1.5 plus 3/20 times 1.5 squared. And you just plug that into your calculator. I'm going to get a value of 0.6375. Part B. I want the probability that x is between 1.5 and 0.5. Well, that is just the same as f of 1.5 minus f of 0.5. So, that's exactly what we're going to do. F of 1.5 minus f of 0.5 is going to equal, well, we know f of 1.5, it's 0.6375, subtracting 1/5 of 0.5 plus 3/20 times 0.5 squared. And when we do that, we get an answer of 0.5. Part C. This is an interesting one. The probability that x equals 1. Now, this is a little bit strange. I'm not going to sketch the function, but I'll kind of just make up a mock function. So suppose that was our function. And say the function, well, the function is not defined when it's less than 0, but that's not important. What it's essentially saying here is work out the area of a line, because it's saying when x equals 1, work out the area of a line. And the area of a line, well, you can't have that. I need to have a region in order to calculate the area. So the probability that x equals 1, so the probability that it has a particular value is 0. So we must have a region. It must be cumulative probabilities less than or equal to. And then part D, find the probability density function of f of x. So this is the interesting part. Not that the rest of the video ain't interesting, but I'll let you be the judge of that. Let's find the PDF. So to get the PDF, we've got to differentiate. So let's differentiate and then fill it in as we go. Alright, so the derivative of 0 is obviously 0. The derivative of this, the derivative of 1/5 of x plus 3 over 20 x squared. So taking the derivative of that. Okay, so we're going to reduce the power by 1 and then times by that value. So you get 1/5 plus, and this is going to be 6 over 20, which is the same as 3 over 10 x. Okay, so we get it's 1/5 plus 3 over 10 x when x is between 0 and 2. So 0 less than or equal to x less than or equal to 2. And then everywhere else, because if I get ddx of 1, I also get 0. So it's going to be 0 otherwise. Remember, when we take the derivative of a constant, we always get 0. Okay, an exam question. So we've got f of x here. It's from January 2010. We've got the cumulative distribution function given, and I'm asked to find the probability that x is less than 0. So the probability that x is less than 0. Well, we have to remember that that is the same as working out f of 0. So the probability that f of 0 less than 0 is also the same, because it's cumulative, it's also the same as less than or equal to 0, because the probability that x equals 0 is actually 0. So less than or equal to 0 is actually the same as less than 0. Little aside there. Right, f of 0, where is that defined? 0 is going to be between -2 and 4, so I'm going to use this part of the function. So all I do is plug in 0 where I have an x. So we get 0 plus 2 over 6, which is 2 over 6, which is simply 1/3. So very handy 2 marks there. And then work out the PDF f of x of x. So we've just done one of those, and in order to do it, we have to differentiate. So I'm going to differentiate 0, I get 0, f of x. I'm also going to get ddx of x plus 2 over 6. So d by dx of x plus 2 over 6. So differentiating that. In order to differentiate this, I'm going to make it a little bit easier for me. I'm going to say, well, that's the same as getting ddx of 1/6 of x plus, well, 2 over 6 is the same as 1/3. Okay, x over 6 is the same as 1/6 of x, and 2 over 6 is the same as 1/3. And then differentiating that, we get 1/6 plus 0, which is just 1/6. And then when I get ddx of 1, that's also 0. So it's going to be 1/6 when x is between -2 and 4. And then everywhere else, it's 0. This is actually a very special function. If it's got a probability of 1/6 everywhere, a little bit of an aside here, it's got a probability of 1/6, oh, it's going the wrong way. Probability of 1/6 everywhere, and it goes from -2 to 4, which is a width of 6. It's actually what we call a continuous uniform distribution, which we will be doing in the next video. So it's a continuous uniform distribution. I can model it using a box. I can see here that my line is not straight. There we go. It's a continuous uniform distribution, like so. And it goes from -2 up to 4. The probability everywhere is 1/6 between, and you see if the width is 6 and the height is 1/6, well, 6 times 1/6 gives me a total area of 1. But anyway, we'll talk about that later. Right, and we got another exam question here. So I've got my, we've actually done some of this already. I need to find the I'm not going to do part A again. We need to find a cumulative distribution function f of x. Now, before I do that, I just want to rewrite f of x here. So using the fact that k is 1/9. So I know that f of x equals, so it's 1/9 times x squared minus 2x plus 2, and it's going to be 1/3 here and then 0 here, and that's between 0 less than x less than or equal to 3. It's 3 less than x less than or equal to 4, and then everywhere else or otherwise. Don't write OW, by the way, it's just me saving time here. Okay, and remember to go from little f of x to big f of x, or from your PDF to your CDF, you integrate. So let's start by integrating. So I'm going to integrate 1/9 of x squared minus 2x plus 2 with respect to x. Okay, so let's integrate this now. I'm going to take out the 9 first and foremost. So 1/9 of x, 1/9, the integral. I'm not happy with that. Let's try that again. Let's go across. So factor out 1/9, the integral of x squared minus 2x plus 2 dx. Okay, so it's going to be 1/9 into 1/3 x cubed minus x squared plus 2x plus c. Okay, now I can introduce the 9th if I wish, but I also know I need to find c now. I need to find c. I know that when x is 0, the probability is going to be equal to 0. So what I can say is, I can say that 1/9 of 1/3 of x cubed minus x squared plus 2x plus c is going to be equal to 0 when x equals 0. When x is 0, this must equal 0. Okay? Because again, we've got a function, dreadfully drawn function. Okay, it's gonna be what's it gonna look like? Between 0 and 3. So I mean, it is a good habit to sketch it. It's gonna look something like this, and then it's between 3 and 4. It has a value of 1/3, so something like that. And the total area underneath this part, between 0 and 4, the total area must be equal to 1. The total area must be equal to 1. That means when x is 0, the total probability is 0. So I can get c here. I'm going to multiply across by 9. I'm going to multiply across by 9, and I'm going to substitute x equal to 0 in. And when I do all that, I actually get c equals 0. So that's quite convenient for me that we get c equals 0 when x is 0. Okay, that's the first part done. Now what I need to do is integrate 1/3 as well. So let's just switch to green for this. So I'm going to integrate 1/3 dx. And when I do that, I get 1/3 of x plus d. And 1/3 of x plus d, 1/3 of x plus d, 1/3 of x plus, 1/3 of x plus 1/3 of d, should I say. 1/3 of d, because if I factor out the 1/3 and then I integrate that, I get x plus d, and then I gotta multiply that 1/3 back in. So you get 1/3 of x plus 1/3 of d must equal 1 when x is 4. So that's the final part where the function is defined. It's 0 elsewhere. So when x is 4, so when x is equal to 4, this must equal 1. So let's substitute 4 and we get that's going to be 4 over 3. 1 take away 4 over 3. 1 take away 4 over 3 is going to give me minus 1 over 3. And then multiplying both sides by 3, we get d equals minus 1. So we get d equal to minus 1. And this function here is going to be, let's rewrite it. So now that I know what d is, we get 1/3 of x minus 1/3. So 1/3 of x minus 1/3. Okay, and this one here, we know c is 0, so we can write it as 1/9. 1/9. Let's write it in here, this one. Because we know what c is, it's 1/9 times 1/3 x cubed minus x squared plus 2x, because we know that c is 0. Alright, and the last part is just to actually write up your cumulative distribution function. So f of x is 0, so it's going to be 0 when x is less than or equal to 0. So when x is less than or equal to 0. Okay. The first one that we integrated was this one. So it's going to be, I'm going to multiply in this 9th here as well. So it's going to be 1 over 27 x cubed minus 1 over 9 x squared plus 2 over 9 x. And it's going to be that when x is bigger than 0 but less than or equal to 3. So when x is bigger than 0 but less than or equal to 3. Alright, when x is bigger than 0 but less than or equal to 3. And then we integrated 1/3, didn't we? When we integrated that, we found it to be 1/3 of x minus 1/3. 1/3 of x minus 1/3, and that's when x is greater than greater than 3 but less than or equal to 4. So x is greater than 3 but less than or equal to 4, and then when x is greater than 4, we know that the final probability must be 1. Just notice here as well, if you might be looking at these going, where is he getting these from? These two come from the integrating and what we are given, and then the other two that I've written down come from the fact that we'll always have a part of it where it's going to be 0, so less than or equal to your lowest bound, and then the last one is always 1, which is going to be bigger than your highest bound. Alright, let's move on. Mean and the variance. Now, hopefully you remember from discrete random variables in your S1 course that the mean, sometimes known as the expected value of x, was I'm trying to remember now off the top of my head how we worked it out. But what I do remember telling you guys was that the variance was the mean of the squares minus the square of the mean. So essentially what I'm getting at is, remember these formulae, okay? The mean, or the expected value of x, just comes from doing the integral of the whole function, but also timesing it by x. So x times the function, and then the variance we do x squared times the function minus the square of the mean. Alright, now this will become a lot clearer once we do a few examples. Okay, On we go. So here we've got a function f of y. It's a probability density function, and I'm asked to work out the expected value of y, or the mean of y. Now the way to do that is we need to integrate between 1 and 3, because it only takes values between 1 and 3, it's 0 elsewhere. We need to integrate between 1 and 3 of y times y over 4. Okay, you may remember it on the previous page. It said x f of x times f of x. The integral between minus infinity and infinity. Alright, in this case the limits are going to be between 1 and 3. 1 and 3 of y times y over 4 dy, which is y squared over 4. So the integral between 1 and 3 of, and I'm going to write this as 1/4 y squared dy. So quarter y squared dy. Now integrating this, we're going to get, that's going to become 3, so I've got to do a quarter divided by 3, which is 1/12. So 1/12 of y cubed, I need to evaluate that between 3 and 1. 3 and 1. And then substituting 3 in, 3 cubed is 27. We get 27 over 12. 27 over 12, subtracting 1 over 12, which is 26 over 12, which is 13 over 6. And the variance of y, comes from the mean of squares minus the square of the mean. So I need the expected value of x squared. I shouldn't be using a little x for that, it should be a big X. Well, I'm going to write y. The expected value of y squared minus the expected value of y squared. Now I know the expected value of y, I've just calculated it. The expected value of y squared comes from doing this, from doing the integral minus infinity to infinity of x squared f of x. So instead of doing x squared, I've got to do y squared f of y. So essentially, let me change colours here. I need to get the integral between 1 and 3 of 1/4 y cubed. So just like this, but instead of doing y squared, I'm doing y cubed, because I'm not multiplying by y this time, I'm multiplying by y squared dy. So plugging that in, we get that's going to be a 4, so we do a quarter divided by 4, which is 16. 1 over 16 y to the 4, and we've got to evaluate that between 1 and 3. So let's do that. Putting 3 in, 3 to the power of 4 is 3, 9, 27, 81. 81 over 16. I'll just leave it as that, 81 over 16, and then put 1 in, we get minus 1 over 16, which is going to give us 80 over 16, and 80 over 16, when you simplify, 80 over 16 is going to break down to, I'm not quite sure off the top of my head, we don't need to do that yet. We don't need to do that. That's just the expected value of y squared. So that's the expected value of y squared. So the variance, I'll have to scuffle down a wee bit, right? The variance of y equals the expected value of y squared, which we've calculated. That's it there. Minus the expected value of y to be squared. So the mean of the squares minus the square of the mean. In this case, 80 over 16. 80 over 16 minus 13 over 6 squared, which is 169 over 36. And then I'm just going to bash that into the calculator. When I do that, we get an answer of 11 over 36. Okay, so the variance, remember, is the mean of the squares minus the square of the mean. The next part, the expected value of 2y minus 3. Again, this requires a bit from our S1. I'll just write it over here. The expected value of a x plus b. So if I transform it linearly, that's the same as a times the expected value of x plus b. So I can just apply that to this. It works for discrete random variables. It also works for continuous random variables. So that is going to equal 2 times the expected value of y minus 3, which is 2 times, well, the expected value of y is 13 over 6, and then we've got to take 3 away. It's going to be 26 over 6, take away 18 over 6, which is going to give us 8 over 6, and 8 over 6 is 4 over 3. And then this one here, the variance of 2y minus 3, well, the variance, and you do need to know these, of 2y minus, sure, I shouldn't write 2y minus 3, what am I doing? Of ay plus b, of a, what about ax, let's stick with x, ax plus b equals a squared times the variance of x. Okay, we ignore the b. Alright, so this, let's change colour again, let's go to black now. Right, so 2y minus 3 is going to be 2 squared times the variance of y. 2 squared is 4, so we get 4 times 11 over 36, which is 44 over 36, and 44 over 36 is 11 over 9. Right, so 4 really quick examples, well, maybe not quick for you, but let's go on and do some exam questions. Okay, here we go. So we've got a continuous random variable again. We need to find the expected value of x, which is the mean of x. So I need to do the integral between 2 and 3 of x times f of x. Now f of x between 2 and 3 is this. The integral between 2 and 3 of 2x times x minus 2 dx. Should have a dx here as well. Okay, I'm going to multiply this out, make life a little bit easier for me. 2, 3, so we get 2x squared minus 4x dx. Scroll down a bit. So when I integrate 2x, I'm going to get 2 over 3 x cubed minus 2x squared. And I need to evaluate that between 2 and 3. Okay, so let's put 3 in here. 3 cubed is 27. 27 times 2 is 54. And then 54 over 3. I'll work that out in a second. 54 over 3. Minus 3 squared is 9. 9 times 2 is 18. So minus 18. And then what I need to do is I need to take away. Let me see, 2 cubed, which is 8, 8 times 2 is 16 over 3, 16 over 3, minus, putting 2 in here, 2 to 4, 4, minus 8, minus 8. Okay, now when you bash that into your calculator, we're going to get 8 over 3. Okie doke, next example. So we got our probability density function, and I need to find the expected value of x. So I need to, I'm going to have to integrate over the whole thing, but remember, and then add them together. So where I've got two functions, I'm actually going to need to do this. The integral between 0 and 1 of 1/3 of x. Remember, the integral over the whole function of x times f of x, right? And that's your mean, which is sometimes known as the expected value of x. So we're going to need to do 1/3 of x dx between there, and I'm going to need to add this part here as well, which is going to be the integral between 1 and 2 of 8x, not x cubed now, it's going to be x to the 4. So I'm going to write it as 8 over 45 x to the power of 4 dx. Okay, doke. So 1/3 is going to become 1/3 x is going to become 1 over 6 x squared. Got to evaluate that between 0 and 1, and adding. This is going to become a 5, and I'm going to multiply that by 5. 45 multiplied by 5 is 225. So it's going to be 8 over 225 times x to the power of 5. And I need to evaluate that between 1 and 2. Okie doke. Right. It would be nicer if that 1 wasn't in the way. There we go. Let's move it down. Beautiful. Okay, substituting in the 1, we're going to get 1 over 6. Substituting in 0, we get 0. Plus, substituting 2 here, 2 to the power of 5 is 32. 32 times 8 is, let me think, 2, 4, 8, 16, 32. 32 times 8 is 256. 256 over 225 minus, and then substituting in the 1, we get 1 to the power of 5 is 1. 1 times 8 over 225 is 8 over 225. You can plug that into your calculator if you wish. When you do that, to 3 significant figures, you're going to get an answer of 1.27. Right, almost there. The mode, the median, and the quartiles. Now, the mode is the value of x which gives the highest point on the PDF. So what you need to do is you differentiate the PDF, and what you do is then you can set it equal to 0, because the gradient must be equal to 0 on the highest point. Okay, the maximum, if you will, the maximum is going to have a derivative equal to 0, and you get the value of x for that. Alright? Or sometimes you can just sketch the curve and work it out from that, but more often than not, you'll have to do that. You'll have to find the derivative, set it equal to 0, similar to finding a local maximum from core. The median is where f of your second quartile is equal to 0.5. Lower quartile, f of Q1 is going to equal to 0.25, and then similarly your upper quartile is going to have a cumulative probability of 0.75. You want any other percentile, suppose you wanted the first decile. So the first decile, well, that would be equal to 0.1. If you wanted the third one, so the 30th percentile, if you will, so the 30th percentile, your cumulative probability would be 0.3. Alright, let's have a look at one more example here. So we've got our continuous random variable x, we've got PDF given. I need to sketch the PDF first, I need to find the mode, then I need to find the CDF, and then finally show that the median lies between these two values. And this will be the last question I'll do. We won't worry about an exam question. They're all similar to this. Right, so on we go. Sketching the PDF. So it's going to have, well, I've got to start with an axis. So let's do that. Start with the axis. I'm going to label the axes as 0 here. Let's give myself a bit of breathing space. 2 there. Okay, now I know that the function is defined only between 0 and 2, and everywhere else it's 0. So we do have probabilities. I shouldn't say defined. It's defined everywhere, but it has probability of 0 everywhere other than between 0 and 2. So, straight lines are getting a wee bit better. Alright, okay. And do remember, you must put them in to get full marks in the exam. The next thing I've got to look at is this. Now, what type of curve or what type of graph is it going to be? It's going to be a quadratic, and it's negative. The value of x squared is negative, which means it's going to have this kind of unhappy shape. All right, so I know it's going to look something like that. The next thing I need to know is where I put my curve? I mean, is it coming down like this, or does it kind of go up a bit like that? So what I'm going to do is I'm going to put 0 in. So when x is 0, what do I get? When x is 0, I get 0, and that will be 0. So 0 take away 0 is 0, and 3 over 10 times 0 is also 0. So it's probably going to come up in this way. Let's see what happens when x is 2. If x is 2, let's see, when x equals 2, that implies that f of x is going to equal, we get 3 over 10 times 2 times 3 is 6, and 6 minus 2 squared, which is 4. So we get 6 minus 4, which is 2. 2 times 3 over 10 is 6 over 10, which is 3 over 5. 3 over 5, so when x is 2, we have a value of 3/5, or, yeah, let's write it as 3/5, or 0.6 if you will. So the curve comes down like that. Okay, not too shabby at all. And then we can drop our dotted line like so. And we also remember that the total area, we know that the total area beneath this curve, or the total probability, must be equal to 1. Okay, find the mode of x. Well, find the mode of x. Now, one thing about my graph that's not brilliant is the fact that I actually don't know if the maximum is here or whether it should have been up here. So what I'm going to do is, like I spoke about, find d dx of the function. So d dx of 3 over 10, not 3 over 10, what am I doing? 3 over 10 times, I'm going to multiply this 3 over 10 in. So I'm going to get the derivative of 9 times x minus 3 over 10 x squared, and that must be equal to 0. So the derivative of this is 9 over 10 minus 6 over 10, which equals 0, and that 9 over 10 minus 6 over 10 is 3 over 10. That's what you know that you're starting to get tired when things are going wrong towards the end of the video. Let's try that one more time. 9 over 10, x, when I get the derivative, is 9 over 10, and minus 6 over 10 x, and that must be equal to 0. So, minus 6 over 10 x must equal minus 9 over 10. Dividing both sides by minus 6 over 10, we get x equals 1.5. So the mode is 1.5. Mode is 1.5. So my graph probably at 1.5, which would be round about here, should be at its highest point. Let's adjust it. Let's adjust the graph just to try and make things nice and neat for the final question. So that's the highest point. So it kind of comes down like so. And then it will come down that way. Okay. Alright, finally, okay, part C, we've got to do the CDF. So let's do the CDF here. And to get the CDF, we've got to integrate. So, I'm going to start by actually writing down my function again, just so that I can see what I'm doing. So f of x, if I remember correctly, was 3 over x, 3 over 10, I'm saying 3 over 10, 3 over 10 times 3x minus x and a half between 0 and 2, and then everywhere else it's 0. So, okay, I gotta integrate this. I'm gonna factor out the 3 over 10 and just integrate 3x minus x squared dx. So we get 3 over 10 into, that becomes 3 over 2 x squared minus 1/3 x plus c. And I know that this must be equal to 0 when x equals 0. Okay, when x is 0, the function, the integral, is equal to 0. Okay, I'm going to multiply across by, well, divide both sides by 3 over 10, so I get 3 over 2, and I'm going to substitute in the 0 here. 3 over 2 times 0 minus 1/3 times 0 plus c equals 0, and that tells me nicely that c is 0. So I know c is 0. So now let's write down the function. Change over to green. So my cumulative distribution function, f of x, will equal, right, well, we know that's going to be 0 when x is less than 0. When x is less than 0. I also know that when x is between 0 and 2, so 0 less than or equal to x less than or equal to 2, the function is going to take this form. Now I can multiply in, remember, let me just rewrite this now, the fact that I know that c is 0, I'm going to multiply in that 3 over 10, so 9 over 20 x squared minus 3 over 30 x. So it's going to be this, 9 over 20 x squared minus 3 over 30 x. And then everywhere else, when, in other words, when x is bigger than 2, it must have a cumulative probability of 1. Right, so that was a slog. Hopefully you found that video useful. I'll be back again, please God, with a shorter video. I'll talk to you again sometime. Best of luck with the revision. Take it easy.